Hi, welcome back to Terra City Retro Programming. For my returning viewers and for anyone that's new, welcome. This is just a YouTube channel that deals with the color computer, um, TRS-80, Radio Shack model, uh, 80s computer. Went into the 90s just a little bit with the Model 3, and then they stopped production. But I'm a home brewer, and I make mostly video games, but I also do math videos, science videos, and other videos as well. So this is one of my science videos for anyone who's interested. I just made it because I felt like it, and maybe it'll pick up some interest from somebody. But what this is it's just a diagram of the periodic table and how to read the periodic table. It's just an example. Now, my pointer, I just started using TRS-80 GP as my emulator after I got Windows 11. The one that I was using, Xroar, I think it wasn't supporting the joystick, my joystick, and I was having some other problems with it. And so I scrapped it, and um, I don't deal with the Color Computer 3. That it does, but it doesn't concern me because I only deal with the 1 and the 2. So the point being is that the screen is smaller on the capture for some reason. I don't know why. I see a much bigger screen, and also my pointer is off. So right now I'm pointing at the hydrogen element as it appears in the periodic table. I'm pointing right inside that box. And you guys probably see it somewhere else. It's like off by a few inches. I don't know why. So just bear with me. So if you don't know how to read the periodic table, if you open up a periodic table, you look at it, there are gases, metals, synthetics, and metalloids. I think that's what's on there. I'm not referencing it right now, but so elements are just the smallest constituent part of matter. So there are like over 100 of them, but some of them are synthetic, and so they're not really elements, but they're on there anyway. So you want to pay attention to the gases, the liquids, which I only think there's 2 liquids, and it's not water, because water is a molecule, not an element. And then you have most of them are gases, and most of them are metals, like silver, gold. Those are all elements. Carbon is an element that's a building block of life, and hydrogen is also a building block of life, if I'm not mistaken. Um, but anyways, I'm not going to get into biology. I primarily like to deal with metals and things like that, but for now, um, and I'm just gonna, so I don't make a mistake, I'm gonna open up my own periodic table here and look at it. So yes, we have solids, gases, liquids, and synthetics, um, metals, and then some of these are metals, metalloids, and non-metals. So I was a little mistaken there. Metals are under solids, okay? And like I said, there's only a couple liquids, and it's not water. Things like, um, things like mercury is a liquid, and we know that's a dangerous heavy metal. Um, and I'm not sure why it's under a liquid. It's a liquid metal, I think. And bromine, I don't know what that is. That's the only. Those are the only 2 liquid elements. The other ones are gases and mostly solids, and a lot of the solids are metals, but not all of them. So, but anyways, a lot of people go through school and they learn this or they forget it. It's not hard to learn, or they never learn it because they're not taught right. It's everyone should be familiar with the periodic table. Um, but anyways, that's just my opinion. Um, so we're gonna look at hydrogen, which is um, the first element listed. So the periodic table is broken down into columns, and there are 18 columns. And then there are several rows, I think 7 rows. And then there's a section that fits in, but I don't understand how it fits in. I don't know why it was drawn like this, to reduce space, but it's hard to understand. So um, there, the columns and um, the rows are periods, and the columns are groups. So there's a way to read it, you know, but I'm not that familiar with it. What I want to focus on is particular elements. So the first one listed is hydrogen. So I'm circling it with my bad pointer coverage here, but it's probably somewhere else. So we're looking at the label comes first, so it just says what it is, hydrogen. And then there's a number. So this number is very important because the periodic table goes from number 1 all the way through 103, I'm sorry, 114. When this book was written back in 2000, this is an old science book, so there might be more now with the synthetics and things, but I don't deal with synthetics, so we're just gonna say there's 100 or so, excluding synthetics, but maybe a little less. So it goes from 1 all the way up to 100 and something. And hydrogen is first, and it happens to be a gas. And if you're looking at the periodic table, there'll be a symbol over here on the right which says if it's a gas or solid, but I left that out. I didn't, I just, this is my rendition of it. It's the way I felt like doing it. You know, if you want to make your own, you can do it your own way, but I did this in like 45 minutes or an hour. That's all the time I had. So, first, it says the element. Then it says the atomic number. So that's its main identifier is atomic number. And the symbol, it's just H for hydrogen. So H2O makes water. So if you had two of these hydrogens in a water, an oxygen that were, bonded together, you would have a water molecule, one water molecule. Oxygen is actually, its atomic number is 8. But anyways, and it's a gas as well. Oxygen and hydrogen are both gases, but when they combine like that, the H2O, you get water, which would be, anyways, a molecule. It wouldn't be an element. So another example of something that's not an element that some people think is an element would be magnetite. So magnetite is found in nature. It's sort of like an ore, and it's actually a mineral, not an element. I thought magnetite was an element for a long time, but it's really it's a what is it called? It's a no, I can't think. It's a mineral. a mineral. Okay, it's actually a mineral and it attracts iron, and its makeup actually is just iron and oxygen. So magnets are found in nature. For people that don't know that, it's not something that you make. It's an ore, it's a mineral that you process, and there's magnets exist in nature, believe it or not, and so does iron piece, so but you can make a magnet. You can make certain metals into magnets using electricity and other methods, but anyway, back to hydrogen. So we have the name, we have the atomic number, we have the symbol. Then there's a number below each of these, and it gets a little confusing because this is the atomic mass. So when we say mass, we're not talking about weight. A lot of people get this confused. Mass is not weight. It's related to weight, but it is not weight. It's not a measurement of weight. Weight is something different. Mass is how much space something takes up. So one hydrogen atom, and let's look over here. I'm circling the atom over here on the right. This is a orbital model, the only one I use. There's other ones, and they're really confusing, and they don't make a lot of sense. They just make things worse. So I only use the orbital example, okay? So this is a hydrogen atom. In the center is the nucleus, and each orbital can contain a certain number of electrons. In this case, hydrogen only has one electron in one orbital shell. The most the first shell can contain would be 2 electrons, unless you had a ion, okay, which would be one, or ions have more or less electrons, and it makes them negatively charged, I believe. But in this case, we only have one electron. The most this shell could contain is 2. So if we had a hydrogen ion, it would have another shell, another orbital with one more electron, I believe, and that would make it negatively charged. So electrons carry a negative charge, and they orbit around the nucleus, and inside the nucleus is a proton and a neutron. So a proton is a positive charged particle. Okay, it's larger than the electron, not by much, and it's usually grouped with a neutron, which has no charge, just a neutral charge, not positive or negative. It changes the mass of the atom. In this case, hydrogen doesn't have a neutron. It's one of those elements that is a little different. It doesn't have a neutron, so this is just a proton. And then, so if you look at this bottom number here in the periodic table, back to this over here, the 1.008. So this is its mass, and its mass is the number of protons and electrons. I'm sorry, the mass is, the number of protons and neutrons combined in the nucleus. So we only have one proton and no neutrons, so that's where the 1 comes from. But if you notice, there's a decimal of 8/1000ths, and to me, this makes, and it's all over the periodic table. None of them are solid numbers. I don't see any that are whole numbers. Um, and this is where it gets really confusing. And so, anyways, let's go back to this first number here. Its atomic number, okay, is also the number of protons in the nucleus. So that's a lot easier for people to understand. The first three elements, hydrogen, it's just a name. We get that. Atomic number, number of protons, that's easy. H is just a symbol. So I would say avoid this unless you need it for something, but just disregard the decimals, and it's the number of protons and neutrons. So if this had a neutron, like most atoms do, this number would be 2. It's just protons plus neutrons equals 2. Okay? The reason they have this decimal here is because of isotopes. So there are 3 hydrogen isotopes, and this is the most common one. 99.95% of the time you're dealing with this isotope. There are 2 others that are very uncommon, and they exist, but it's kind of like splitting hairs. Like, who really cares? Like, I don't. But scientists do. So what they do is some of the isotopes, they have, it's just a different number of neutrons and protons, okay, and electrons. I don't know. The atom is different. It has different numbers of electrons and protons and neutrons and things. And what they do is they average it together, and it's just an atomic average. And I'm not sure exactly how the formula works, but I don't know. I think they use occurrence as part of it and things like that. So if you're looking at something that's 95.95% of the time, or 99 point whatever, the occurrence of the other 2 is very low, and so they just add it in there. It makes a pain in the ass of things, but that's what you're looking at here, and that's the whole story. Anyways, I'm not I'm not a scientist, but I know about this stuff because I've had teacher training and things like that in science. So I don't know everything, but that's the scoop. And I may have made a mistake or two, but most of this stuff is on target. So say if you had an element that you were looking at in the periodic table, and this number was 2 down here. If you subtract that number from this number, then it would tell you the number of neutrons. So if you had like 5 protons and the number down here was 10, 10 minus 5 equals 5 neutrons. So that's really what this number down here is for. So you can estimate the number of neutrons, and that's it. Thanks for watching. I just wrote this in P mode for high resolution, and there's probably, I don't know why this is like this right now. Let me get rid of that. It won't list like that. So literally 19 lines of code in about 45 minutes. You can make your own diagram, your own atom diagram. And if I made this interactive, which would take forever, it'd be like a project that a bunch of people would work on, or I don't have time for it by myself, but you could make it interactive so that you can like have a list somehow of all the elements, and then you click on here, you click from a list up here, and then you put it in here, and then it calculates this, and it changes the model over here. That's a real a real application, a real possibility, but I don't have time for it. I'm constantly making new programs, and I have so many of them. I can't finish them all, and I don't know. But every time I get a new idea, I just type it in, man. I don't know. This computer has some real limitations, though. Memory is a problem. I ran out of memory the other day when I'm working on my video game Tales of Suburbia, so I had to restructure the directory and size down the programs because there's not a lot of memory. It's only like 22.5K or something like that. It runs out really quick when you're doing graphic stuff, heavy graphics and stuff. Once you get up to about 550 lines, anything past that, heavy graphics, you're going to have to cut the program up into smaller pieces and use a disk directory to manage them. And that's what I'm going through with my game right now. And I just needed the version once in a while. So I came up with this. And again, I lost my train of thought. I don't know, talking about um, shortening programs or something. I don't know. Yeah, so that's it. I am going to cut this off. Anybody wants to make any comments, go right ahead. I want to hear what you guys have to say. I haven't had any comments in a couple of months, and before it used to be nonstop. Hopefully somebody has something to say about this. I'm sure some people might. Um, I don't know, but that's all I can think of right now. So I will see you guys again in the near future, and thanks for watching. Bye.